In this video, we're going to talk about how to solve and graph and compound inequalities. Starting with this first example, we have basically it's just two inequalities in one problem. We can solve them separately and then graph them on the same graph. So here we have 3x plus 2 is less than 14. To start isolating that x, I'm going to first subtract 2 from both sides, and I'll get 3x is less than 12. And then to get x by itself, we'll divide both sides by 3. We get x is less than 4. Then I'll solve the second one separately. First, to isolate the x, I'm going to add 5 to both sides, which will get me 2x is greater than, negative 6, and then divided by 2. We get x is greater than negative 3. So when we graph and inequalities, I first just plot my points. So I'm going to have negative 3 here, positive 4 here, and then I'll put 0 in the middle so we can kind of see what's going on here. X is less than 4, so that's going to mean we have an open dot at 4. X is greater than negative 3 means we have a, just erase my whole thing there. We have an open dot at negative 3. And with our and inequalities, we always graph and shade in the center between our 2 points because it's an x value that satisfies both inequalities, which also means that it's just anything that's in between our 2 numbers here. Looking at the next one, this is another way you can be presented an and inequality, and it's still our 2 separate inequalities, but it's kind of just mushed into one. And you can kind of see we have 2 inequality symbols in one inequality, which is kind of weird to look at because we haven't seen that yet. But what happens when we have to solve these? Well, we want to get that variable by itself in the center. And so what we're going to do is just use our inverse operations, but we're going to do it on all 3 parts of the inequality. So I'm not just going to subtract 9 from the middle, but I'm going to subtract it from the left and subtract it from the right. Negative 6 minus 9 is going to get us a negative 15, less than, these cancel, leaving us just with 3n in the center, which is also less than 21 minus 9, which is going to get us 12. So notice what happened. It's just like solving an inequality, except you do it 3 times, so because we technically have 3 sides instead of 2. The last step is to divide everything by 3 to get n by itself, because they'll cancel in the middle. Negative 15 divided by 3 is negative 5. That's less than n, which is less than 4 when we do 12 divided by 3. And now when we graph this, I'm going to plot negative 5, 4, and my 0 in the center here. Open dots at both negative 5 and positive 4, since these are both less than symbols. And with all our and inequalities, we shade in the middle because that x is sandwiched in between negative 5 and positive 4. All right, we have one more example here. Doesn't look too bad. It really looks very similar to the one we just did. And so let's just kind of go about and try and get r by itself. To do that, we would divide everything by negative 3. The one thing we have to remember, anytime we have inequalities, if you multiply or divide by a negative, you have to flip the inequality symbol. That still is the same with compound inequalities. But with the and inequalities, since we're dividing everything by a negative here, our inequality symbols are going to flip, both of them. So here, we're going to get negative 8. These cancel, leaving us with r in the middle, and we get positive 3. So negative 8 is less than r, which is less than or equal to 3. The key is, anytime you have an and inequality that's written as one inequality with 2 inequality symbols in it, they should be either less than symbols or less than or equal to symbols. And then the other key to make sure you did it right is that this should be the smaller number and this should be the larger number. So left is the smaller number, right is the larger number. Okay, so when we graph this now, we are going to graph it just as we did the last one. We'll put negative 8, 3, 0. We're going to have an open dot at -8, but we're going to have a closed dot at 3 because it's a less than or equal to symbol with that +3. Shade in the middle. So no matter what way you're presented your inequality, you're either solving the two separate inequalities or solving one. You're just dealing with 3 sides instead of 2 sides. And when you graph, you always plot the points the same way as you normally would, but then you always shade in the middle with our and inequalities.